Hey, welcome to the final video of chapter 6.5 and the final video of this course. In this video, we'll be talking about the change of base for logarithms, which gives us a powerful way to change the base of the logarithms. It's very easy and can be very useful. So what I mean by change the base is that a lot of times we see logarithms that might look like log 2 of, say, 27. Now, this is great and all until you look at your calculator and you notice that it only has a natural log button and a log 10 button. So it would be really helpful if we could evaluate it in terms of some constant k, and then a log 10, and some other number in there as well. So that's what we're going to talk about in this video. And it'll end up actually being a pretty nice formula. Okay, so what we're going to do first is take our log 2 to the 27, and we want to change it to be base 10. But first, we're going to start like we usually do and just set it equal to y. So that actually tells us that 2 to the y is 27. So this is our usual definition of logarithm, that the logarithm, when we're setting it equal to a number, we just need to solve this equation. And now what we're going to do is we want a log 10, so we're just going to involve one. We're just going to take the log 10 of both sides. So we get log 10 of 2 to the y equals log 10 of 27. Okay, good. So we have some log 10s there. We're going to apply our exponent rule. That's going to let us bring down that y. So we'll get y times log 10 of 2 equals log 10 of 27. And I'm going to put a little space in the bottom. Now we'll divide the log 10 of 2 to the other side. So in essence, we've solved for y. And we can see from above that y is that log 2 of 27. So that we have log 2 of 27 equals log 10 of 27 over log 10 of 2. And so that's our change of base. We've been able to switch from having an expression of a logarithm in base 2 to an expression, albeit with 2 logarithms in base 10. So our general formula for change of base. So our change of base from A to D is log A of B equals log D of B divided by log D of A. So a very nice formula. And we'll see an example right now of how that can be used to evaluate some equations. So for our first example, we're going to look at log base 1/4 of 32 equals the square root of 2. So This comes off first as seeming difficult because if we're looking for the solution to this equation, that's not so easy to find. And you can kind of puzzle over what that is for a bit if you can do like a guess and check solution, but it'll probably be hard. However, what we can do is change to base 2. And there's a couple reasons why this might be a good idea. First, 1/4, that's a power of 2. 32 is a power of 2. And the square root of 2 is a power of 2. So we'll actually be able to evaluate most of these, all of these, in terms of logarithm with base 2. So we'll rewrite using our change of base. It's going to be log 2 of what's inside the parentheses. So that's 32 square root of 2. And we'll divide that by what's the base of above with the logarithm. So log 2 of 1/4. Now, this is pretty good progress. We're actually going to apply our product rule as well. And take a second to think about where I might be applying this product rule. Okay, so hopefully you identified that we'd be doing the product rule on the top. That kind of makes sense. We have a 32 times a root 2. And on the bottom, we're not multiplying anything together. All right, so that's pretty good. We have an expression, and now this is actually really easy to evaluate. I'm just going to skip ahead and evaluate it because I think these are all pretty straightforward. But yeah, feel free to pause the video and work out these 3 log calculations on your own. And these are the answers right here. You should get 5 plus a half divided by -2. And if we start to combine, if we combine the top as a single fraction, we'll get 11/2 divided by -2, or that's -11/4. So there we go. That's what our log of 1/4 of 32 root 2 is. It's -11/4. And so we were able to evaluate that by just using the change of base for the logarithm. All right, and the last thing we're going to talk about is just a cute identity that comes out of this change of base. So it's going to start with a question. Given log A of B, what is log B of A? This is something that usually might be like a tough question because the B you're plugging in isn't necessarily related closely to the A, but this actually has a nice answer. We can answer it just looking at the change of base. So given log A of B, we'll change it to base B. So that's the same as log B of B over log B of A. So that's just plugging into our change of base formula. And then one of our properties of logs is that log B of B is just 1. So this comes out to log b of a. So that's actually pretty nice. Log a of b equals 1 over log b of a. As a quick example, log 2 of, pick a power of 2, let's say 64. That's equal to 6. And then log of 64 of 2. That's going to be what we can plug into 64. Take that power to get 2 out. And if we take 1 over 6, so we take the 6th root, we'll get back 2. So yeah, we get that this is 1 over log 2 of 64. Yeah, so it's quite a nice formula. Pretty cool. Might be a fun test question to ask as well. That might be tough to figure out if you don't have this specific rule memorized. All right. I hope you enjoyed these videos.